What is protein synthesis?
Protein synthesis is the process in which cells make proteins. Proteins are a large macromolecule made from long amino acid chains. We need proteins in order to repair or replace cells. In protein synthesis, there are two major steps responsible: transcription and translation.
Starting in the nucleus, transcription is the first step in protein synthesis, which is the process where information is copied into mRNA. To start off, we have DNA. DNA is short for deoxyribonucleic acid, which has a double helix structure. In this diagram, we can see this is a gene. This section right here shows the bond pairings in the DNA. The pairings for DNA goes to A bonds with T, vice versa, C bonds with G. However, in RNA, A bonds with U, C bonds with G, and that is because DNA uses thymine and where RNA uses uracil. Since DNA is the master copy, it will not leave the nucleus since there is no replacement for it. So the DNA has to find a new way to communicate instructions. But how? That's where mRNA comes in to save the day. mRNA is short for messenger RNA, and it's its job to get the message to rRNA, ribosomes, and tRNA. It leaves the nucleus, travels to the cytoplasm, and attaches to a ribosome made of rRNA, which will build protein in the next step called translation.
Translation is the second step to protein synthesis and is the process in which a protein is synthesized using the information carried by mRNA. Translation occurs in the ribosome, which is like a factory for protein synthesis. A ribosome is a complex structure that consists of several rRNA, or ribosomal RNA. Translation happens in 3 steps: initiation, elongation, and termination. During initiation, the mRNA will slide down the ribosome until the start codon, AUG, reaches the P site. A ribosome consists of 3 initiation sites: the A site, the P site, and the E site. tRNA, or transfer RNA, dwell in the cytoplasm and carry an amino acid on them, which is a monomer for a protein. If you didn't remember, a monomer is a building block. A bunch of amino acids together form a protein. mRNA directs which tRNA are transferred. To be transferred, they must find and bond with complementary bases. So, how do they? Teacher, what is an amino acid?
They are compounds that are organic and contain amino carboxylate groups.
What do they have to do with proteins?
Good question. Amino acids are the building blocks, so if you take a bunch together and bond them, it makes a protein.
What bond keeps them together?
A peptide between 2 amino acids holds it together. It's called a polypeptide bond.
During elongation, the second step of translation, the tRNA binds with the mRNA. But how? Codons. A group of 3 nucleotides on mRNA is a codon, while a group of 3 nucleotides on tRNA is an anticodon. Remember, in RNA, A binds with U and C binds with G, and vice versa. Our start codon, AUG, will bond with the anticodon, UAC. Remember how tRNA carries amino acids? Well, mRNA codons code for these, and the start codon codes for methionine. After binding with mRNA, the tRNA will detach and leave its amino acid behind to form the amino acid chain. You may be wondering how to tell which codons code for which amino acids. Well, there's a chart for that. Let me show you how to use it. For this demonstration, we will be using our next codon, which is CUC. If you look at the chart, you will notice that on the left side, there are 4 rows labeled U, C, A, and G. This will be for our first nucleotide, which is C, so let's look for the C row. On the top of the chart, you will notice that there are 4 columns labeled U, C, A, and G. This will be for our second nucleotide, which is U. So you will look for the U column. You will find the square in which the C row and the U column intersect in order to work for the third nucleotide. On the right side, you notice that in each row, there are 4 tinier rows labeled U, C, A, and G. This will be for our third nucleotide, which is C. So, in the C row, we will look for the tinier C row and find what the tinier C row is in the square that the C row and the U column combine. We will notice that while in this square, all the All the different codons code for the same amino acid, but this is not the same for every square. Our codon CUC codes for leucine. This process will continue down the mRNA to form the amino acid chain, which is held together by peptide bonds, until the final stage of translation, termination. Termination happens when the ribosome reaches a stop codon, UAA, UAG, or UGA. Since there are no tRNA that can bind with these codons, the ribosome recognizes the process as complete. The protein is then released, and that is the process of protein synthesis.
Girl, you know I